Welcome to this session. And this session will be giving the first examples on convolution so that we understand the concept of convolution from what we defined previously. So let's project the screen. So the first question is to find the convolution of t and t squared. So let's see how we solve this. So solution for this. So I'll say let us call f of t to be the function t and g of t to be the second function, t squared. And then by definition, we know that convolution of f and g, denoted by f star g, is a function of t given by the integral 0 to t, and then multiplied by f of t minus v times g of v. Integral is taken with respect to v. So this is by definition. Now, with this definition, it means that we need to define the function f of t minus v. So this one implies if f of t is t, then f of t minus v is given by t minus v. Simply the input becomes t minus v, while this one is t. And then g of v would be simply given by, if g of t is t squared, then g of v must be v squared. So therefore, if we call this one, this definition, this we call it 1, this one we call 2, and this definition we call it 3, then we say substituting 1 and 2 in 3, we get that convolution of f and g will be given by the integral 0 to t. Now f of t minus v is t minus v, and then g of v is v squared, and then we multiply by dv. Now the problem just reduces to integrating this function, so we should be given by integral from 0 to t. So v squared times t will be t v squared. V times minus v is minus v cubed. And then we integrate with respect to v. This will give us, now this one with respect to v will be t v power 3 divided by 3 minus v power 4 divided by 4, and then v from 0 to v equals to t. So which will give us t times v cubed, which is t cubed, divided by 3 minus t power 4 over 4. So this is the upper limit, minus, when you replace v for 0, this part will be 0, this will also be 0. 0 minus 0 is 0. So we'll get t cubed times t is t power 4. So t power 4 divided by 3 minus t power 4 divided by 4 defines f convoluted with g. So this is the same as 1 over 12 t power 4. So this becomes the solution to that particular problem. And then example 2, problem 2, or appetizer number 2, we'll have find the convolution of 2t and t cubed. So the first thing to solve this one, we have to know what functions we are dealing with. So we'll say let us call f of t to be the function 2t and g of t be given by t cubed. So we know that the convolution of f and g is given by the integral 0 to t, and then f of t minus v multiplied by g of v, and then dv. This by definition. So then now, it means that here, f of t minus v. Now, if you know f of t, then you should be able to get f of t minus v by simply replacing the role of t to t minus v. So this will be given by 2 into t minus v, which will give us 2t minus 2v. And then g of v will be given by simply v power 3, because g of t is t cubed. So now, if we call this one formula 1, call this one 2, call this one 3, then we say using 2 and 3 in 1, we get that the convolution of f and g will be given by the integral from 0 to t. Now, where there's f of t minus v, we put this 2t minus 2v multiplied by g of v, which is v power 3 dv. So this will give us integral 0 to t. 2 by this will give us 2t v power 3 minus 2 v power 4. And then integration is done with respect to v. Now this will be given by, so this will be v power 4 over 2t v power 4 over 4, which will just be given as t v power 4 over 2 minus 2 v power 5 divided by 5, and then v from 0 to v equals to t. So we'll replace v for t. So lower limit will be 0 because we have v here and we have v here. So we'll have, so t power 4 times t is t power 5. So t power 5 over 2 minus, this will be 2 t power 5 over 5. This is upper limit, and then minus 0, the lower limit is 0. So when you work out this, you get 1 over 10 t power 5. So therefore, this is the answer for convolution of 2t and t power 3. So this will be the solution to that particular problem. The next example will demonstrate how to show that commutative property for convolution works with a specific example or specific functions. Thank you.